Hello and welcome to Atmosoft Tech Talks, a live show where we discuss everything you need to know about software development and technology in business. I'm Natasha, your host, and joining me today is our COO, Bill, a solutions architect at Atmosoft. Hi, Bill. Thank you for joining us today.
Hey, how are you doing?
Good. How about you?
Not too bad. Hanging in there.
Fantastic.
Friday.
Yeah,
Woo!
I know. The
Weekend.
weekend.
Yeah,
I'm
yeah.
excited to sleep in and do some packing.
Yeah, yeah. Oh, you're moving.
Yeah, I'm moving at the start of August. I'm going to be moving
Oh,
across states, so it's going to be a long, tedious move. But
yeah, yeah. Well, if you need help,
yeah, I'll reach out.
yeah, for sure.
Okay, today we're going to be talking about it's. Oh, my brain just blank. Oh, today we are talking about the in. It isn't it design
Yeah, secure design.
secure design. Yeah,
Yeah, yeah.
my brain just blanked. It's Friday. My
You're
brain.
okay.
Okay. Okay. So let's dive into some questions about secure design. So, can you describe a situation where you identified an insecure design in a software system? How did you address it?
Okay, so one of the things I look for, we talked earlier in this week about security in depth, right? And so we talked about the concept of an in-tiered or a layered architecture, even if you're working with a monolith or a microservice. Okay,
Mhm.
so the first thing that I'll always start looking for when I'm doing a security audit of code is to make sure that we're validating inputs all the way through the different layers. So in an instance, I found some validation that wasn't happening at the lowest layer before we're saving to the database. We weren't checking the values that were being passed in, and that could have led to a security vulnerability or some type of the invalid code in the data. I mean, when you think about security, you also got to think about I also like to think about kind of integrity of the data too, right? So if I'm not validating my data and I'm just shoving stuff into a database, I may be, it's not good when you type Oklahoma and then you misspell it, or you're using state codes, you're typing in a city and you forget a letter, and then you kind of have stuff matching later. So you want to you do the integrity validation too, but also there you would do a security check. So what we did is we identified the vulnerability. We weren't validating some inputs that were being passed into several of the functions. So we basically wrote up a bug. We didn't deploy. We wrote up a bug and then went in and addressed the issues in the code so that the code was doing validation in all three layers.
Okay, yeah, fantastic. That sounds like an extension to being able to sanitize your input data, correct?
Yeah, absolutely, 100%.
Yeah. Okay, then how does the concept of defense in depth influence your design decisions?
So again, we're looking for, they can be logical or physical separations for the application that we're working on, right? So most of the time, I think everything, I kind of think about it in logical terms, even if they're physically separated, and so that each point when we're transitioning from one portion of the application to the other, we want to take into consideration, basically, when a handoff happens, that we're applying strategies to do the sanitization, input validation. We're not, as you transition through the layers. For example, let's say I post something up to an API, and we read out all the form fields, and then we pass all of those form fields into our business logic layer, and you also want to make sure that this goes with the defense in depth. So I'm going to take this just a little bit. So you want to make sure that you're also not um, that your fortifications are solid, and you don't have any leak. So for example, if I'm passing a bunch of form fields, when I call my function, I just want to pass the string values of those, or numeric values of those form fields, to my business logic layer. I don't
Mhm.
actually want to pass in like the request object from the server that's handling the request, right? Because there should be a separation, a clear separation there, and it's the web server's job to do the web server things like handle the request objects, get you all the HTTP headers, and do all that work. So when you transition down into the layers, you want to make sure that you have a solid separation there, and you're not passing objects or references that really belong in one layer to another layer, because that can open you up to, you have a hole in your defense, right? I'm just grabbing the request object and I'm passing the request object to my business layer. Well, and then that also reduces the usability of that business logic. So typically in .NET, which is what I'll use for my primary example, when I build a service layer piece, it's usually going to be a DLL, right?
Okay.
So it's going to be a library that's added to the web. It's added to the web project, and on the server side, it's creating instances of objects from that library, and we're passing data around. When I pass in the whole request object from when I pass in the whole request object from the server, what's happening is now my library becomes bound to being it needs to have a request object. So now that makes my library is not portable. I can't reuse that code in another project that's not a website, because otherwise I have to figure out how to build up that request object. There's patterns you can do to work around this, but typically you want to, I like to get down to the base types. It's okay to pass a object, right? Like you could have a model object that you populate from the form, and then you pass the model object, but you never want to pass the actual form object or anything having to do with the web server down the stack, because that's going to kind of open you up. So that's one of the things to take into consideration when you're doing defense in depth is make sure that you have, well-defined boundaries, and you're not accidentally crossing those boundaries. That's a very easy error to make, is, oh, I'm not going to, because it's a little more work up front, right? I have to build this model object that I'm going to read from these form fields that are being passed up, and I'm going to put them in the model, and then I'm going to pass the model. And then you think, why don't I just pass the request object? And then you're kind of crossing layers, and that leads to kind of spaghetti code, and then your objects get these weird dependencies where, as you move down the stack, you have something called object, or sorry, it's not object, but as you move down the stack, you don't want to be passing down references that are particular to, the web server. You don't want to be passing stuff into your business logic layer, because that's you're kind of getting spaghetti code. You could end up with weird circular references. It'll work, but as your product evolves and someone says, oh, we want to do a WPF application that for internal use only, and we want it to process these forms, and so then you can't just grab that library and put it in there without making a bunch of modifications, because you actually created a kind of a back reference to, I need a request object. That's how this get form fields grabs all of its data, sanitizes it, and puts it into the database. And so you kind of want to separate that out and make sure you're not crossing logical boundaries of on your tiers. And the same thing goes with the data access layer, right? So and this is all kind of encompassing defense in depth. So on your data access layer, right, usually you're going to use some type of ORM. That is an object relational mapper, and that is something that takes it basically takes your database and exposes it as objects for you, so you can work against those objects. Now, the tricky thing is you can think of those objects as models, right? So let's just say I have a customer table. I have a customer representation in my ORM, and it has a bunch of properties. And I think, oh, I'm just going to return a customer. But you don't want to return the customer, because that is a database. It's not a database specific class the way that most ORM works, but it's a database specific object, right? And it has attributes that tell Entity Framework what it's doing, and max length, and this is the key, this isn't the key. You don't want to pass that object back up the stack, right? Because that's database stuff. It needs to stay in the database section of its castle, right? Think about boom, 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 right? Stay right here. And so you don't want to just pass that customer object back, but you have to write a little bit more code to do it the right way. And I think that's where a lot of people just be like, oh, we'll just send the customer object back. But you really want to send back it's an exact copy, but you really want to send back a model object that's independent of the class that's used for the ORM. I don't want to be passing the customer object in my DAO back up through the rest of it. So, let's just say they hit a website, we have a grid on display, and we're going to display a list of customers. And so we go down to the business logic layer, we get the list of customers from the database, and the database starts sending that stuff back. Right here is where you don't want to make the mistake of just sending the customer object back up, right? Because I want to send a model object, which is an independent object that's not directly tied to the ORM, because I really don't want all the overhead. It's just easier. It's a better design, and it's a better design because the rest of the code doesn't need to care about the database, the data access layer, the persistence layer. It doesn't care how it works. And when it's talking to someone external from, and so this would be another assembly, right? So it would be the access, the data access layer would be whatever company data access, and you want it to, it's going to do some work, and it's going to do some work on a database. But what you want it to return when it's communicating with another assembly, or it's communicating to the web server, because you could go direct from the web server to your DAO, right? That's you don't really, if your business logic is just pass through, just take the business logic layer out, right? And at some point in time in the future, if you come up and you need to have more business intelligence in that middle layer, you can put that middle layer in at the time. But don't just put a layer in just to have a layer in. It just makes everything more complicated, and you don't really need to do that. But in this case, we're going from the client back up to the web server via API. The API is making call to the business logic layer, because we do have business logic around customers. And then we're calling down into the DAO. We don't want the DAO to send back its version of the customer object that it interacts with the database with. It's just we're bleeding and we're poking holes in the defense. So I don't know of any vulnerabilities there, like specific vulnerabilities, but it may be a vulnerability area. So I always want to take that and I want to turn it into, call it kind of a generic, I call them model objects. I want to turn it into a model object, and then I want to pass that model object back. The cool thing about that is using that model pattern and not just working with the ORM classes directly, is later on I can modify that, right? Without touching anything on the database. It's going to send back a customer model object. And let's just say the UI needs a property like last login date, or that's actually a poor example, but let's just say it needs some type of computed property that doesn't necessarily get saved to the database, but we can represent that in the model object. So now the model objects can evolve outside of the ORM, right? Because if we have the ORM, you could add the property there too, even though, actually, can you do that? I'm not sure you can do that. I don't think I can put, actually, yeah, you can. You could put a property on there that's just for the UI, but then you're bleeding things over, right? It's not good, because that's supposed to be the representation of what the customer table looks like in the database. And if I go add a bunch of properties to it and I start shipping them back and it has nothing to do with the database, it just gets confusing. But if I have this model object, I can say, hey, the business layer needs me to return the customer this way. And it needs to have, I need to calculate these values from other data sets that I have, or maybe have proper computed properties or that kind of thing. And then you're passing back that model. And that model is a direct representation of what the business logic layer needs. And it's independent of the data access layer working with that customer object internally inside of its own assembly. And it gives you a very good separation. You're not actually accidentally poking holes in your defenses. You want to make sure you keep those layers pretty closed. Like you really don't want to be, it's okay for assemblies to do a bunch of random stuff inside. It's okay for classes to do a bunch of random stuff inside, but all that stuff doesn't necessarily need to be exposed externally to that particular object. In fact, if I was doing the models, I would have a fourth assembly, which would probably comprise of all my services and my model objects that I'm using. And then that would be referenced by both the business logic layer and the data access layer. And then, so they can both use it, but they're kind of communicating. There was ambassador pattern is something that I posted on today. This would be kind of an example of that, of kind of like the ambassador pattern, because what you're doing is you're basically putting in kind of a translation layer between the two. and then feeding it back objects that are common to the whole system and not objects that should be common to a particular area of the system.
Okay. So it sounds like pretty much you want the layers because anytime that you pass a layer, there should be something that makes it so that you're not just releasing the data willy-nilly throughout the layers.
Yeah.
And also you want your layers to make sense and not just be there for like as a defense.
Yeah. And again, like what exactly what you were saying, you don't want to be passing down the different types of, you don't want to be passing down layer specific information.
Yeah.
Because you want all of your layers to be agnostics to the layers in front and behind, because that helps you with reusability,
Mhm.
which is another thing we were talking about. Because if my middle layer doesn't care where I'm being instantiated, I don't have to be instantiated in a web server because I'm not expecting a request object, and I
Mhm.
don't have references to anything in the web server, then that code can be plucked out, and or the assembly can be added to other projects and used in different cases. And then you have kind of a unified, on the enterprise level, you have kind of a unified view of your business logic. When we're working with this particular customer orders screen, or we're working with customers and orders, we can use this assembly, and then that assembly gets published, and then other areas in the enterprise that are consuming that, then they all get the updates, right? And so it's not because you want to reuse code, you don't want to rewrite it where you can. There's instances where you can't do that, but in most cases, I really want all that customer logic to be the same across all of the systems that are interacting with the customers. I don't want to deviate and have a customer assembly over here for system one and a customer assembly over here for system two, and they're both interacting with the same database. And maybe this guy gets updated with the new rule set. Maybe they decided we don't want to sell products to California anymore, and then this system is still able to sell products to California because they didn't get the memo and they didn't get the update. And so you have to think about those things when you're designing your application. You have to think about those things when you're trying to defend against even external or internal people.
Yeah, for sure. It's easier if you have them all have the stuff that they can share somewhere separate where they're all sharing it and then they can grab it when they need it rather than all of them having their own version of it and then it could potentially not get updated in one of
Yeah.
them and then suddenly you have a whole issue.
Yeah, and you could run into issues where team two didn't get the memo, so they didn't update their interaction with the customer database, and it breaks your application because maybe you made a breaking change, and you're only supposed to put certain values in this column now, and it used to be maybe it was open and you could put any data you want in there or any string or number or whatever, and now they're writing invalid data to that column because you kind of tightened the restriction. The business requirements for that column change, and so you're tightening the restriction. And so when they come back in, or when you come back in and you're trying to read those records, the value is now invalid, and then the system is not responding the way it's supposed to, and you start getting really weird errors actually. Like hopefully if typically I guess you can't really get away. Like that's the whole point of databases is you can share them. So typically, a couple weeks ago we talked about integration, and with integration, the worst type of integration you could do is integrating at the database level.
Yep.
Because especially if you're integrating with a custom off-the-shelf application like Microsoft's Navision or other products like that, if you're writing directly to the database and you're bypassing all of their business logic layer, you could be writing invalid values, or maybe there's some weird code in there that when this particular thing gets inserted, we update this other column over here in this table that you didn't even know was related because the application has some logic around what happens when that field gets toggled or the time entry stamp gets updated or whatever, and so you can run into a lot of problems. So and you want to make sure that when other people are interacting with via published assemblies in the enterprise or whatever, when other people are interacting with your particular application, your database, you want to make sure that the rule sets are common across all of them.
Yeah. Okay. Well, that was very informative. Are you ready for our last question?
Yeah, let's do one more.
All right, fantastic. So the last question that we have for today is how do you make sure the security is integrated into the design process from the very beginning rather than being an afterthought?
Okay, so the best way to do that is through training and education. These are the most common problems, and we as an enterprise have decided that we want to mitigate the risks associated with these problems, and
Mhm.
so this is the approach we're going to take. And then that gets communicated to the leads, and then the leads communicate that to their team. And it's best kind of to do organizational wide, but it could be something that's team specific. So
Yeah.
so the best way is just communication up front, and then you add into your code review process the security checks, right? We're worried about these 5 things from a security standpoint. The list may be bigger, it may be smaller, like maybe you're only worried about 2, but we're worried particularly about these 5 things. So when you're reviewing the code, part of your code review process should be, those 5 items are on the checklist, and you go through and you say, okay, yeah, we got we're not leaking data. All the functions are sanitizing their inputs, and we're sanitizing and validating our inputs. We're returning errors correctly. We're catching errors where we're supposed to. We're not just letting errors bubble up to the top layer of the stack and then crash the entire application, and so on and so forth. So that all is about communication, and that's also good too, because you're managing expectations.
Yeah.
So you're setting the expectation that we expect your code to be secure, and we're not just going to say, Tasha, make sure your code is secure. We're going to explicitly state, Natasha, you need to validate the input in the JavaScript on the UI before you pass the input up to us. And then maybe you're like, well, I don't know how to catch all the if they put in a bunch of HTML or looking for tags, and then someone on the team would be like, hey, Natasha, there's a JavaScript library that does this, and you can just reference the library, and then you just call the sanitize function, and it returns you a safe version, even if there's script tags and everything in it, and then you would use that library. And so that again, that's a whole communication thing. And then pushing back if you don't understand. If someone says just make sure your code is secure, that's a worthless statement. I'm sorry.
Yeah.
Like, secure your code. Okay, how? What?
How? Yeah. What do I need to?
I went out on the web. There's like 5,000 different vulnerabilities. Do I have to code for all of them? And
Yeah.
in most cases, no. Most cases, if you hit these 5, 10 general things and make sure that you're following um, these particular patterns, then you're covering 90% of it. A lot of times in development, it'll be I always call it the 80-20 rule. So back in the day, we used to have a lot of just people would get really excited about a new low code product. One of them was it's called Light something. I don't know. It was pretty cool. And a client that I had really, really wanted to use it. So we got into it and we're building it up, and we got 80% of the way there. And then the last 20% was way harder than
Yeah.
than
The first idea.
before it. The point where I was driving to was you can get good enough coverage. Okay, so like if I'm covering the top 10 most uh, uh, insecure coding practices, you're probably going to get 80%, 90% of the way there. And that last 5% is stuff that's like, I'd have to spend like 500 hours on your website trying to derive this one particular key, making hundreds of thousands of requests, and someone would notice that kind of thing. And so
Yeah.
so I mean, there's always, everything costs money. And every hour that someone is working costs money, and you have to take that in consideration. So if there's an attack vector that is extremely unlikely to occur, like they have to do these 53 steps first, and then if they pass in the character A at the last step, then you get this, you get access to the system. But all those 53 steps have to pass perfectly. That you really, because things cost money, you really can't spend time perfecting it. But there's a lot of things you can do that get you most of the way there, and in most cases that's going to be good enough, and it's going to be a cost-effective solution versus I have to solve every security problem that's ever been considered, invented, or thought of. That's just going to take a lifetime to do.
Well, it's the same logic as when you have a lock on your house. Like, oh, this lock is going to make it so that when I lock it, it's much harder for them to come in if they're trying to. But ultimately, they could break the window, or
Yeah,
ultimately they could just like learn lock picking. But all
yeah,
those are way more of a higher
more
type of
difficult.
thing for
Yeah.
them to do than just opening your door and walking in. So it's just about like deferring them enough, like it's way too hard that they'd rather go somewhere else.
Go to someone else's house,
Yeah.
which is unfortunate, but that is the
Yeah.
world we live in.
Yeah, well, like, that's just how it comes down to security though too, right? Like, with everything, even bikes, it's like you put a bike chain on and, like, someone, yeah, could cut through it, but if there's a bike that it doesn't have a chain on right next to yours, they're probably not gonna cut through
Yeah,
yours,
yeah,
they're just gonna take that other bike.
take the other bike. Yep.
Yeah.
Yep. Agreed.
Yeah, I think that's a lot of the times. Like, in a perfect world, it would be lovely if we had the time to do all the security and everything that we need to do so that literally nothing could break through. It's like a fortress and no one can get through except unless we let them or something like that. But in reality, like, businesses have limited funding for security or IT stuff. And so just getting good enough to where you can make sure that for the most part, you're probably not going to have a data breach is good enough.
Yeah. And so, I mean, the best way to secure a computer is turn it off.
Yep. Yeah, don't have it running.
Yeah.
If it's not on, they can't like connect to anything.
Can't hack it if it's not on the internet. Actually, no, do that. But yeah, most cases. Again,
Yeah.
it's always conditional.
Yeah. Or like not clicking on links, or there's a bunch
Yeah,
of
yeah.
other stuff that you can like learn about. But a
Yeah.
lot of it's like you can't just be afraid forever. Like eventually you might have to just click a link and you might just mess up, and you should know how to do things after you've messed up too.
Yeah. Yep. Yep.
Okay. Is there anything else we want to close with?
I just want to tell everyone have a great weekend. Main reason for doing this is just kind of share information. We're passionate about technology, and we really would, if your organization needs some help, we really would like to be the company that you pick to do that. And I hope everyone has a good weekend. And I don't know about everybody else, but maybe a lot of people probably take a Monday off because Tuesday is a holiday. Happy 4th of July to everybody. And I hope everyone has a great weekend, and celebrate with the ones you love, have some barbecues, drink some beers if you're into that, and just go out and enjoy life a little bit because it's short.
Yep. Have a good weekend. I hope you spend it doing something you love. And other than that, I'm going to close us out for the week.
Yep.
So that's it from us. We'll see you guys next week with a new topic or theme. If you have a theme that you want to submit, please let us know in the comments or in DMs. Either way is good, and we would love to talk about anything that you're interested in. Otherwise, we'll just keep going through the things that interest us.
Yeah, for sure. All right. Bye, everybody.
Bye.